Hello and welcome back to Civil Engineering Exam Prep. And today we are pondering over this question, why asphalt heals itself and concrete never really can. The strange material that refuses to stay broken, that is asphalt. Now, imagine if you cut your skin and after a few days later you observe that it has started repairing itself. No engineering surprise. Living things heal, right? But now imagine a road doing the same thing. No workers, no asphalt paver, no maintenance crew, just a crack that slowly becomes smaller over time. Sounds impossible, right? Yet, researchers have observed exactly this phenomenon in asphalt pavement. Tiny cracks can partially disappear, damage can reduce, mechanical properties can recover, and this raises one of the strangest questions in highway engineering. Why can asphalt heal itself while concrete almost never can? The answer lies in chemistry, physics, molecular motion, and one of the most overlooked properties of material. Let's go to chapter 1, the great pavement misconception. Most students think concrete is strong and asphalt is weak. Simple. But engineers know that it's not the real story. The real difference is concrete behaves like a rigid crystal and asphalt behaves like a very slow moving liquid disguised as a solid. And that changes everything. Chapter 2, asphalt is secretly moving all the time. Take a concrete slab, place it on a road. Its molecules are essentially locked into a position. The structure is rigid, the particles cannot rearrange themselves significantly. Now look at bitumen. Bitumen is weird, extremely weird. It is neither true liquid nor a true solid. It exists in a strange state called viscoelasticity. At highway temperature, its molecules are constantly moving, slowly, very slowly, but moving. The road you drove on today is not completely still. It is creeping, it is flowing, it is rearranging itself molecule by molecule. Chapter 3, the birth of a crack. Every wheel load creates stress. Millions of vehicles pass. Tiny cracks begin forming. At first, they are microscopic, invisible. No engineer notices, but the pavement does. These tiny cracks represent stored energy. The material wants to relieve that energy. The question becomes, can it reconnect? Chapter 4, why asphalt gets a second chance. Here's where the magic happens. Suppose traffic stops, night arrives, the pavement is going to rest. Bitumen molecules are continuing their motion. Given sufficient time, they begin diffusing across the crack interface. Think of two drops of honey touching. Eventually, they are going to merge. The molecules don't know there was ever a boundary. The crack start losing its identity. Researchers call this molecular healing, and it's one of the coolest phenomena in pavement engineering. Chapter 5, why concrete cannot do the same. Concrete faces a different and difficult reality. When concrete cracks, the crack cuts through cement paste, aggregate interfaces, and hydration product. The material structure is totally, essentially fractured. Concrete molecules cannot simply flow back together. The molecular mobility is gone. The particles are trapped. The crack remains. Concrete remembers, and asphalt, bitumen, forgets. Chapter 6, the sleeping road theory. One of the most fascinating discoveries came when researchers noticed roads sometimes recover stiffness after periods of rest. Not because someone repaired them, because healing occurred internally. Imagine two highways. Highway A, continuous traffic. Highway B, frequent respirates. Sometimes Highway B survives significantly longer. The road benefits from the slip, from the rest, just like humans. Chapter 7, nature invented this first. Think about skin, bones, trees. Nature rarely builds perfectly rigid system. Nature prefers system capable of recovery, flexibility, adaptation, healing. Asphalt and bitumen accidentally follow the same philosophy. Concrete follows a different one, which is resistance. Chapter 8, The Strange Trade-off. If asphalt can heal itself, why don't we build everything with asphalt? Because healing comes at a price. The same molecular mobility that allows healing also causes rutting, permanent deformation, and creep. The road heals because it can move. The road deforms it because it can move. Both originate from the same property. This is one of the engineering's most beautiful trade-offs. Chapter 9. Engineers are trying to create immortal roads. Modern researchers are experimenting with steel fibers, microcapsule, rejuvenating oils, induction heating, nanomaterial. The goal? Roads that actively repair themselves. Not in decades, not in years, but in hours. Imagine a highway healing overnight while nobody is observing. The future may be closer than most people think. Chapter 10, The Deeper Lesson. This story isn't really about pavement. It is about two philosophies of survival. Concrete says, I will survive by resisting damage. Asphalt says, I will survive by recovering from damage. Nature overwhelmingly prefers the second strategy. And perhaps that's why asphalt possesses something concrete truly never can, the ability to heal. The next time you drive on a highway at midnight, remember the road beneath your tires is not completely inert. It is not completely dead. Its molecules are still moving, still rearranging, still trying to repair the tiny wounds inflicted by millions of vehicle tires. And somehow, beneath your car, a microscopic crack may be quietly disappearing without anyone ever noticing. So that's it for today's podcast. I will see you next one. Till then, take care. Bye bye.